Morning children. Already we have seen application of derivative rate of change and then tangent and normal, increase and decreasing. Then we have seen maximum minima which topic I taught, that is without a derivative test how to find the maximum and minimum. Now next another topic, one of the most important topic, first derivative test, that we say local maximum, local minimum. Local, why we say local, means very nearest value. We are taking very nearest value for testing. This is a maximum or minimum. Clear to you? So first derivative means local maximum and local minimum. So what is the first derivative? It is quite the important topic and easiest one. So try to understand what I am saying here. Now see, let y equal to f of x is a real valued function, is a real valued function defined on its domain, defined on its domain. And let x is equal to a, which belongs to its domain. Now, what first derivative is saying? Step number 1. Find the f dash of x. Find the f dash of x. Now, let f dash of x equal to 0. So that we get x. So that get value of x. Value of x. Okay. Say x is equal to, I am taking c. Okay, fine. Otherwise, here we have taken a. So, say x is equal to a. Okay, fine. Now, what is step number 2? If f dash of x sign changes from, if f dash of x sign changes from negative to, from left to right, this is direction always left to right, from left to right, negative to positive, at x is equal to a, implies fx is a local minimum. Clear to you what I am saying? If f dash of x sign changes from left to right, negative to positive, at x is equal to a, we say fx is local, a minimum, and then replace x by a, and then f of a is local, and f of a is local minimum value. Clear to you? Now, if f dash of x sign changes from left to right, again left direction is left from left to right, sign changes from left to right, positive to negative, at x is equal to a, implies fx is local minimum. Clear to you what I am saying? So, and f of a is called local minimum. So, local, that is negative to positive, that is positive to negative, that is local maximum. Local maximum, and its and f of a is called local maximum value. Clear to you? Local maximum value. Now see what I told you, if f dash of x sign changes from negative to positive, that is local minimum. If the sign f dash of x changes from left to right, that is positive to negative, then that is local maximum. Suppose if there is no change, that is if f dash of x does not change in sign, I will give you example, take change in sign, that is understood from where to where, from left to right, always direction is left to right, then fx is called, that is x is equal to a, is called point of inflection. Clear to you? Point of inflection. This is one of the most important definition. Once again, I will give you example, 2 example I will give you. Now, what a definition is saying, you find the f dash of x, let f dash of x equal to 0, so that you get a value of x. So say whatever, suppose here is one value, we are checking maximum value at one value. If you have two value, so nearest left value, nearest right value, you take it and check the sign. If f dash of x sign changes from negative to positive, we say local maximum. And the same point, if f dash of x changes from positive to negative, then we say local maximum. If there is no change in sign, means positive, positive. Left side is also positive and right side is also positive. Suppose left side is negative, right side is also negative. If there is no change in sign, we say that is a point of inflection. Clear to you? This is a definition. Now let us see example. Let us see example. Are you clear to you this definition? Sir, better this is nothing is difficult. Try to understand what I am saying. Just one example is enough for you. How to check local, how to find the local maximum, local minimum value. Now for example, I am taking, suppose f of x equal to, that is x minus 2 ka. Do you must know simple differentiation. Nothing is difficult than whole cube. So what is the question? F of x equal to x minus 2 ka whole power 4 into x plus 3 ka whole cube. Find the maximum minimum value. Find the local maximum, local minimum. Local maximum, local minimum means what I told you. That is first derivative test. If any means maybe test is failed. That means point of inflection. Okay, let us move. Now f dash of x equal to product of x minus 2 ka whole power 4. Keep it. This is 3 into x plus 3 ka whole square. Now plus x plus 3 ka whole cube. Keep constant. Now differentiation of this 4 into x minus 2 ka whole cube. Now I am taking common here. What is common? You must bring this into factorization form. So that is x minus 2 ka whole cube is common and x plus 2 ka whole square is common. Remaining here 3 into x minus 2, that is 3x minus 6, and then here is remaining 4 into x plus 3, so that is 4x plus 12. Now finally what we have, x minus 2, you should take care of this part. If you are getting value as a mistake, then the entire part is wrong. That's ignore mind. So this is, we are getting 7x and then this is a plus 6. Okay, fine. Now let f, what step I told you, let f dash of x equal to 0. This implies the value of x we are getting, that is 2, and then this is x minus 2 ka whole square, that is minus 2. Then we are getting minus 6 by 7. F dash of x means this equal to 0, x equal to 2. This equal to 0, minus 2. This equal to 0, minus 6 by 7. So we have how many values here? 3 values. Each value you have to check left at or right at. Now I am going for testing. First value I am taking x is equal to 2. What I told you, left at x is equal to 2 and right at x is equal to 2. Am I correct? Right at x is equal to 2. Okay, fine. Very nearest left value, take it 1.9. Very nearest right value, take it 2.1. Okay, fine. Keep it in f dash of x. I need a sign about positive, negative. I don't want value. You check whether positive, negative. If you keep 1.9, it becomes negative. Am I correct? This is final step. This before taking 0, we brought the f dash of x into factorization form. I am keeping here, the 3 terms are within product. That's why I am checking positive, negative. If I keep here 1.9, it becomes negative. If I keep here 1.9, this is always positive because of whole square. If I keep here 2, this becomes positive. The sign I am getting negative. Clear? Now come to 2.1. That's each value left, right value. That's ignore mind. F 2.1. If I keep here 2.1 f dash of x, that becomes positive. This becomes positive. This becomes positive. Positive. What definition is saying? If the sign changes from left to right, negative to positive, implies fx is local maximum. Local minimum. Local minimum. Don't get confused. That is local minimum. And its local minimum values. And its local minimum values. Minimum values. Whatever the value substitute in f of x, that is f of 2 equal to, we are getting 0. 2 minus 2, automatically it becomes 0. Are you clear? Now how many values here? We have, there are 3 values. Let us see remaining value. Another value I am taking. Next one, at x is equal to what? Minus 2. Now again same condition, left at x is equal to minus 2 and right at x is equal to minus 2. Left at x is equal to minus 2, minus 2.1, and right at x is equal to minus 1.9. Am I correct? Now keep it in where testing is always f dash of x and the value always f of x, that's keep in mind. Now f dash of x, now replace x by minus 2.1, definitely it becomes negative, and minus 2.1 it becomes positive, minus 2.1, that is a 14 point something, am I correct? Minus 7 into, so 7 into minus 2.1, so that is 14, that is 1.4, it becomes positive, it becomes positive, am I correct? So that is equal to total we will get negative, total we will get negative. So if I keep minus 1.9 in f dash of x, that is the first part is minus 1 negative, and then again here we are getting this is a positive, minus 1.9 again I think this is a positive. So that is equal to see 1.9 into 7 multiply 63 balance 6. No, this is a negative, this is positive, am I correct? This is negative we are getting, so that means positive. So again we have to check here is also again which part, this part also let me check. So this one is okay, minus 2 point means negative, and this is positive, okay fine. So that is 2.1 into 7, what we will get it is 7, 14, that is we are getting 14.7, 14.7 means we are getting this is a totally positive, am I correct now? Minus 14.7, this is negative, this is negative. So negative, negative, we are getting positive, here is also positive, so that means there is no implies f dash of x does not change sign, does not. Take it very care for this calculation, that's keep your mind. If the calculation is wrong, then you will get an answer, the wrong answer, that's keep your mind. So if you are, if you have every concept in your mind and your calculation is wrong, then completely you will lose your marks. So you should take care at the time of doing calculation. F dash of x does not change in sign, change in sign implies x is equal to minus 2 is called, what is it? Is called the point of inflection, point of inflection. Now next one more point we have, that is third point, that is x is equal to minus 6 by 7. Again left at x is equal to minus 6 by 7 and right at x is equal to minus 6 by 7. Minus 6 by 7 matlab approximately 0.9 something, am I correct? So I am taking x is equal to left value minus 0.1, minus 1 I am taking, here right means x is equal to minus 0.6 or 7 I am taking, okay fine. So left right value I am taking. Now, so f dash of x equal to, first one is negative, I am keeping here. First one is negative, next one is positive. Suppose if I keep minus, then minus we are getting, that becomes positive. If I keep minus 0.7, that is f dash of x equal to minus 0.7, it becomes negative, it becomes positive. Minus 0.7 minus 0.7, that is 49, 4.9, that is again positive, I am getting equal to negative. If the sign changes from positive to negative, implies fx is what? If a sign changes from positive to negative implies fx is a local maximum, and its maximum value is, that is f of minus 6 by 7, that is equal to minus 6 by 7 minus 2 ka whole power 4 and minus 6 by 7 plus 3 ka whole cube, and simplify you will get answer, okay fine. So this is very good example I have taken. So we are getting 3 testing here. At x is equal to 2, sign changes from negative to positive, f dash of x, that's why we say local minimum, and local minimum value is here. And we are getting x is equal to minus 2, f dash of x does not change in sign positive to positive we are getting, that's why we say this minus 2 is called the point of inflection. And x is equal to minus 6 by 7, we are getting left to right, sign changes from positive to negative, we say local maximum. Then simplify you will get answer. Are you clear how to do? So whatever the values you are getting of x, you have to check left and right value, so you comes to do the testing, okay fine. Local maximum or local minimum. So this is one algebraic polynomial question I have taken. Let me take one trigonometric question, okay, how to find the local maximum, local minimum using first derivative test, okay, clear. Now let us take another example. Example number 2, I am taking the f of x equal to sin x plus cos x sin x plus cos x. The value of x lies between maybe 0 to 2 pi, maybe 0 to 2 pi. If it is 0 to 2 pi, what we have to do, that's I will explain to you. Now here as per question 0 to pi by 2, I am taking the example. Now what is the procedure? Usual f dash of x, then becomes cos x minus sin x. Now f dash of x equal to 0, f dash of x equal to 0. This implies cos x is equal to what we will get it, sin x, implies tan x is equal to 1. Tan x is equal to 1. When we will get positive 1? Tan, yesterday also I explained you this part. Minus 1 when we will get, and plus 1, that is a first quadrant, and again third quadrant, tan 5 by 4, etc. This becomes. So this implies x is equal to pi by 4, 5 pi by 4, etc. Now here the interval they are saying 0 to pi by 2. So we have, therefore we have only one value which belongs to 0 to 90 degree open interval. Suppose 0 to pi, then you have to take this interval also. 0 to 2 pi, again you have to take all these values. Clear to you? That is the difference, nothing is difficulty here. So now we have only one value, pi by 4. So what is nearest to pi by 4? Left at pi by 4, right at pi by 4. At x is equal to pi by 4, I am saying left at x is equal to pi by 4. Pi by 4 means 45 degree. Right at x is equal to right at x. Each value you have to check left and the right value. 45, nearest to known value take it, 30 degree. Okay, where you have to substitute this value? F dash of x, don't forget. F dash of x equal to cos 30 minus sin 30. What is cos 30 value? Cos 30 is root 3 by 2. Sin 30 is 1 by 2. So positive. Am I correct? Now right value 45 nearest to known value, that is 60 degree. So f dash of x equal to, here you need exact value, then only you can decide positive or negative. It is not in multiplication, it is not factorized. This is a trig ratio. So that is equal to cos x, cos 60 degree minus sin 60 degree. Am I correct? Cos 60 is 1 by 2, this is minus root 3 by 2, it becomes a negative. Now what sign changes from positive to negative? This implies fx is a local maximum. Fx is a local maximum, and its maximum values, that is that is f of pi by 4, that is equal to sin pi by 4 or plus cos pi by 4. So that is equal to 1 by root 2 plus 1 by root 2, that is equal to root 2. Clear to you? So local maximum, local minimum means what? First derivative test. So what I told you, first derivative test is step number 1, f dash of x. Now let f dash of x equal to 0, so that we get value of x. Whatever you are getting the roots of this x, then each value very nearest to left, very nearest to right. If the sign is value लेके कहाँ पे substitute करना है? f dash of x. Suppose if the sign f dash of x changes from positive to negative, we say local maximum, and if you need the value, substitute in f of x. Now if the f dash of x sign changes from positive to negative to positive, then we say local minimum. Clear to you? If there is no change, what I told you, that is point of inflection. Students, take more practice. This is just I am introducing the topic. You need a lot of practice. Be confident, be confident, be confident. Thank you so much.